Welcome, Calculus. This is Section 8.1, Basic Integration Rules. Essential question is, what are some of the integration tricks you learn in this section? Let's begin. So this is a review of a lot of different integrations you might do. So this first problem right here, integral of 4 over x squared plus 9. And you got to look at this structure and go, where have I seen something like this before? Well, what you've seen is instead of this 9, x squared, the same thing as 3 squared. And so when you have like a number or no variable over x squared plus something squared, this is related to arctangent or inverse tangent. So your integral here, I'm going to take that 4, I'm going to push it outside. So this is just 1 up here. And this looks very similar to the formula for arctangent you should have memorized. If you don't, write down, and you're going to need to memorize it. So again, I can rewrite this as 4 times the integral of 1 over x squared plus 3 squared dx. And so that's going to be, when you actually evaluate that integral, it is going to end up being 4 times 1/3 arctangent of x over 3 plus c. And there's your answer. Now this one, this is different. It's a 4x on top. And I have an x squared plus 9. You start seeing that structure there, you might think U-substitution. Your u is going to be the bigger polynomial in this case, so u is x squared plus 9. That would make your du the derivative of this, which is 2x dx. And you'll notice I have 4x dx here on the top, but that doesn't quite work out. What you're going to do with that 4 is you're going to split it up into 2 times 2. So this 2x dx right here all goes away. That combines, that turns into du. And so then we say 2 times the integral of 1 over, this turns into x squared plus 9 turns into u. So when you evaluate that integral, you're going to get 2 times the ln of absolute value of u plus c. And if you plug in that u, you got to put your stuff back in. 2 times ln of the absolute value of x squared plus 9 plus c. And there's your final answer. Okay, so let's look at this differently. What about this one? 4x squared over x squared plus 9. You might look at that and go, how do I do this one? Well, when you have a case where they're the same degree or there's a higher degree polynomial on the top, you have to do division. Polynomial division. Go back to your Algebra 2 days. So you're dividing 4x squared and divide it by x squared plus 9. So the way you do this is I go, okay, x squared, since this is the highest term out here of the divisor, I don't know if that's the right word, and you have 4x squared right here. Well, x squared, think of this as x squared times what is 4x squared, and it's going to be 4. So 4 times x squared is 4x squared. 4 times 9 is 36. You're actually going to be subtracting just like you would in long division, and these cancel out to 0, and this is left with negative 36. This is your remainder here. So rewriting this in long division form is going to be the integral of 4 minus 36 over x squared plus 9 dx. Now we can integrate this. So the integral of 4 is just going to be 4x. That's something you can figure out, right? Negative 36 over x squared plus 9. Notice from that first problem, this looks like our arctangent problem. That 9 is 3 squared. So I can integrate this and bring that 36 out. It's going to be minus 36 times 1 over 3 arctangent of x over 3 plus c. And there's our answer. I don't need to simplify. Okay, so let's evaluate this one. All right, getting a little bit more difficult here. So I have 2 terms on top. The neat thing we can do when you have multiple terms on top and 1 term on bottom is we can break this up into separate fractions. Because as is right there, you can't really do anything with it. So it's 0 to 1 of x over square root of 4 minus x squared plus the integral from 0 to 1 of 3 over square root of 4 minus x squared dx. And both these are dx. So when you evaluate this one on the left, notice I have negative 4x squared and I have an x. This looks like this is an x squared and this is an x. This is a U-substitution problem. Try to split these up right here. So I'm going to say my u is going to be 4 minus x squared. Du is negative 2x dx. So when you plug that in, and I don't have a negative 2, I have to create the negative 2 and then have the reciprocal, negative 1/2, being multiplied out here. So I get negative 1/2 times the integral of 1 over square root of u, du. I'm not going to worry about changing these. The way I like doing this is substitute the stuff back in and still use the 0 to 1. What you're going to get here when you integrate that, that's the same thing as negative 1/2 times the integral of u to the negative 1/2 power du, which when you work on that kind of problem is going to give you negative 1/2. Integral of this is going to be u to the 1/2, positive 1/2 power, times the reciprocal 2 plus c. Actually, we don't do plus c in this case. And those cancel out, so I'm just left with negative square root of u, which is going to be negative square root, I'm doing the work down here, of 4 minus x squared from 0 to 1. When you plug those in, I'm plugging the 1 first, it becomes negative square root of 4 minus 1 minus negative square root of 4 minus 0. So it's going to be plus 2 minus square root of 3. Okay, that's just for this one. Now let's go over to this problem. I have to make a little bit more room here. This problem right here, what does this look like? Well, 4 minus x squared, I can rewrite that as the integral from 0 to 1 of 3 over square root of 2 squared plus x squared. Oh, not plus x squared. Minus x squared dx. And for this one, this is another one of those inverse trigs. And this, it looks like arc sine. So that actually integrates to 3 times arc sine of x over 2. And again, something to memorize here. From 0 to 1. So when I plug in 1, I get 3 times arc sine, or inverse sine, of 1/2, minus 3 times arc sine of 0. So arc sine of 1/2, well, what is that? Now think back to your unit circle. Where does 1/2 happen for sine? That happens, if I do my 3 spokes like this, sine is the y values. It's going to happen right here. Where's that going to happen? That's going to happen right here. And what's that value for, what's that degree right there in radians? That's going to be pi over 6. So this is 3 times pi over 6 minus 3 arc sine of 0. So sine of 0, that's the y values, happens right there. What's the radians right there? Well, it's 3 times 0. So your answer for this part is just 3 pi over 6, which is to pi over 2. So your final answer is going to be those two parts together. Negative square root of 3 plus 2 plus pi over 2. Yeah, there was a lot of things going on there. These can be a little long. Next one. Find this one, this integral right here, integral of cotangent of ln of sine of x. So if I'm looking at a problem like this, I am thinking U-substitution, especially when you see logs and something outside of logs. That's a good guess. And a good guess of what your U is going to be is whatever's inside that log. So that might be a guess. First, you might say, well, maybe it's just sine of x. And du might be cosine of x, dx. Okay, you can do it that way. Let's see what happens. You're going to get the integral. Oh, but I don't have cosine of x, I have cotangent. That doesn't work at all. So it's going to be something different. And this is where you might play with a few different ideas. So I'm going to be crazy here and say my u is the ln of sine of x. Ln of sine of x, derivative of that, derivative of ln of something is 1 over that something, sine of x, times the derivative of the inside, which is going to be cosine of x, dx. What's cosine of x over sine of x? Well, that is just cotangent of x dx. Hey, so this part's my u, and these two parts are my du's. So they combine. This is just integral of u du, which is going to be u squared over 2 plus c, which comes out to ln of sine of x squared over 2 plus c. All right, one more. So find tangent squared of 2x. Again, looking kind of weird. So first thing I'm going to guess is tangent squared of something that's not just x, U-substitution. So u is 2x du equals 2 dx. Okay, cool. And I don't have a 2 for that dx, but I'm going to create a 2, so I must multiply by 1/2. So it's 1/2 times the integral of tangent squared of u du. Okay, what do I do with this? I don't know. Well, we can rewrite this as 1/2 times the integral of secant squared of u minus 1. Because remember, tangent squared is secant squared minus 1. Because you can't integrate tangent squared, but you can integrate secant squared. Integral of secant squared is just tangent. So the answer is 1/2 times tangent of u minus u plus c. And if you substitute back in your 2x, 1/2 tangent of 2x minus 2x plus c. There you go. All right, I'm going to save some examples for class, and that's it for this lesson.